Hey there, science fans! Today we're diving into the mind-blowing world of quantum chips, tiny technological marvels that are poised to revolutionize the future. Imagine a computer chip so powerful that it makes even the most advanced supercomputers look like toys. That's the promise of quantum chips. But what exactly are these mysterious chips and how do they work their magic? Well, buckle up because we're about to embark on an exciting journey into the realm of quantum computing. In simple terms, a quantum chip is like a super-powered brain for computers. Just like our brains use neurons to process information, quantum chips use the principles of quantum mechanics to perform calculations at speeds that would make your head spin. These chips are based on the fascinating behavior of tiny particles like atoms and photons, which can exist in multiple states at once. This mind-boggling concept, known as superposition, allows quantum chips to tackle problems that would take classical computers billions of years to solve. It's like having a calculator that can calculate all the possible answers to a problem simultaneously. The story of quantum chips begins in the early 1980s, when the brilliant physicist Richard Feynman first proposed the idea of using quantum mechanics for computation. Back then, it was just a theoretical concept, like something straight out of a science fiction novel. Fast forward a couple of decades, and scientists started making significant breakthroughs in the field of quantum mechanics. In the late 1990s and early 2000s, researchers at companies like IBM and Google started building the first rudimentary quantum computers. These early quantum computers were like the Wright brothers' first airplane, primitive, experimental, and far from practical for everyday use. They were incredibly sensitive to their surroundings and could only perform a limited number of calculations before losing their quantum state. However, as the years went by, researchers made steady progress in improving the design and stability of quantum chips. Today, we have quantum computers that are significantly more powerful and reliable than their predecessors. Now you might be wondering, how are quantum chips different from the chips in our smartphones and laptops? Well, the key difference lies in the way they process information. Classical computer chips, also known as CPUs, central processing units, use bits to store and process data. A bit can be either a 0 or a 1, just like a light switch can be either on or off. These bits are like tiny electrical switches that flip between two states to represent data. On the other hand, quantum chips use qubits, which are like super-powered bits. A qubit can be a 0, a 1, or both at the same time. It's like a dimmer switch that can be set to different levels of brightness. This mind-bending ability of qubits, thanks to superposition, allows quantum chips to perform multiple calculations simultaneously, making them exponentially faster than classical chips for certain tasks. Think of it this way. Imagine you're searching for a specific grain of sand on a beach. A classical computer would have to examine each grain of sand one by one until it finds the right one. But a quantum computer could analyze all the grains of sand at once, making the search lightning fast. Alright, I know what you're thinking. This quantum stuff sounds pretty complicated, and you're right, it is a complex topic. But don't worry, I'm here to break it down for you. Imagine a coin spinning in the air. Before it lands, it's in a state of superposition. It's both heads and tails at the same time. That's kind of what's happening with qubits in a quantum chip. They're in this fuzzy, uncertain state until we measure them. Now these qubits are incredibly sensitive. Even the tiniest disturbance, like a change in temperature or vibration, can knock them out of their quantum state, leading to errors. That's why quantum chips are kept in ultra-cold environments, close to absolute zero, to minimize interference. Another key concept in quantum computing is entanglement. This is like an invisible link between two qubits, no matter how far apart they are. When you measure the state of one entangled qubit, you instantly know the state of the other, even if they're miles away. It's like magic, but it's real science. Now that we have a basic understanding of how quantum chips work, let's talk about their incredible potential. Quantum chips are expected to revolutionize various fields, from medicine to materials science to artificial intelligence. In medicine, quantum computers could help develop new drugs and therapies by simulating the behavior of molecules at the atomic level. This could lead to the discovery of personalized medicines tailored to an individual's genetic makeup. Imagine a world where diseases like cancer and Alzheimer's are a thing of the past. In the realm of artificial intelligence, quantum computers could enable us to create AI systems that are far more intelligent and capable than anything we have today. These AI systems could assist us in solving complex problems like climate change, poverty, and disease. Cybersecurity is another area where quantum chips could have a profound impact. Quantum computers could be used to create unbreakable encryption algorithms, making our data and communications secure from even the most sophisticated cyber attacks. While the future of quantum computing looks incredibly promising, there are still several challenges that scientists need to overcome before quantum chips become commonplace. One of the biggest challenges is building quantum computers that are large and stable enough to tackle real-world problems. Right now, current quantum computers are still relatively small and honestly, pretty prone to errors. Maintaining the fragile quantum state of qubits is a delicate dance that requires cutting-edge technology and constant refinement. Another challenge is developing quantum algorithms, which are these specialized instructions that tell quantum computers how to solve specific problems. Designing efficient quantum algorithms is a complex task that requires a deep understanding of both quantum mechanics and computer science. Furthermore, there's the issue of cost. Building and maintaining quantum computers is an expensive endeavor, requiring specialized equipment and expertise. Making this technology more accessible and affordable is crucial for its widespread adoption. Despite these challenges, the field of quantum computing is rapidly advancing, thanks to the tireless efforts of brilliant minds around the world. Companies like IBM, Google, and Intel are leading the charge in quantum chip development, investing heavily in research and development. IBM, for instance, has been at the forefront of quantum computing for decades. They've built some of the most advanced quantum computers to date, and they're constantly pushing the boundaries of what's possible with this technology. Google, another tech giant, has also made significant strides in quantum computing. In 2019, they claimed to have achieved quantum supremacy with their Sycamore processor, which reportedly performed a calculation in 200 seconds that would have taken a classical supercomputer 10,000 years to complete. Intel, known for its dominance in the traditional chip market, is also a major player in the quantum computing race. They're developing silicon-based quantum chips, leveraging their expertise in semiconductor manufacturing to create more scalable and commercially viable quantum computers. In conclusion, quantum chips represent a paradigm shift in computing technology, promising to revolutionize countless aspects of our lives. While there are still hurdles to overcome, the rapid pace of progress in this field is truly remarkable. As quantum computers become more powerful, stable, and accessible, we can expect to witness groundbreaking advancements in medicine, artificial intelligence, cybersecurity, and beyond. The future powered by quantum chips is brimming with exciting possibilities, limited only by our imagination. Just as the invention of the transistor and the integrated circuit paved the way for the digital revolution, quantum chips have the potential to usher in a new era of technological marvels, transforming our world in ways we can only begin to imagine. So buckle up and get ready for the quantum revolution. It's going to be an exhilarating ride. Okay, let's tackle some of your burning questions. First up, when will quantum computers be available to the public? Well, that's the million-dollar question. While it's difficult to give an exact timeline, experts believe that it might still be a few decades before we see quantum computers in our homes. But hey, remember when smartphones were a futuristic concept? Technology moves fast. Next, will quantum computers replace our current computers? Not so fast. Quantum computers are amazing for certain tasks like breaking complex codes or simulating molecules, but they're not meant to replace our trusty laptops and smartphones. Think of them as specialized tools for specific jobs. And finally, is quantum computing safe? Quantum computing itself is safe, but like any technology, it can be used for both good and bad purposes. That's why it's important to have ethical guidelines and regulations in place as this technology continues to develop.